Now we have just concluded reviewing an A-B-C analysis on page number 12. And as I indicated several times during the review of page number 12, you certainly need data processing support in order to generate this particular application. For your review, and again to maintain continuity between the notebook and the screen formats that we are providing you with, we have taken page number 12 and actually broken that page into two screen formats. The first screen format addresses the first part number up on the top in the left-hand column, which is part number T7061, and we conclude with this screen format with the part number down at the bottom left-hand column, which is part number S5251. Now, if you wanted to, you could go back to page number 12 in a notebook and highlight below part number S5251 to indicate that that is our breaking point between the two screen formats that we're going to review. Both of these screen formats, incidentally, are in the notebook following page number 12, which are page numbers 12-1 and 12-2. Now, in many cases, you are not going to have the type of layout that we're showing you in this particular screen format. And the reason for that, if you remember from page number 12, if you look at the second column from the left, we start off with the item card count of 1, and then we go to 13 and 43 and so forth. That means that all the part numbers from item card count 2 to 12 are not shown. In your particular program, you will have all of the part numbers shown. And again, depending on the software that you select, you should be able to browse up or down through the entire inventory ABC application. So again, this is another format where we're trying to utilize the data in the notebook with an actual data processing screen capture. So if you would please now go to the next screen format, which is identical to page 12-2. You'll notice that that particular screen format by part number, which is identical to item number, in the upper left-hand column, starts off with part number N, M as in Mary, 7868, and then it concludes with the last item at the bottom of the left-hand column, which is M3742. Again, I'm not going to go through the heading and all of the data elements relative to this particular screen format. However, the selection of the A, B, and C items are going to follow with the following subsequent pages, as I indicated previously as we were reviewing page number 12. Turn to page 13, and here I have a little homework exercise for you. We have 12 part numbers listed, starting at the left-hand side. You notice we have our annual usage in units. That comes off of the inventory record card. We have the unit cost of the item, and that is listed as the middle column. Now here's what you're going to do. You're going to multiply the annual usage times the unit cost, and therefore you're going to fill in that second column from the right called annual usage times unit cost. Another term for that is annual usage value. There's only 12 calculations involved, so with a little handheld, computer or calculator, it's not going to take long to do this. Now, that right-hand column says rank. What you're going to do is you're going to select the part number that has the highest annual usage value and rank that 1. Then you go to the next highest annual, 2, 3, and 4. So that right-hand column randomly is going to show you 1 through 12. Now, if you turn to page 14, what you're going to do is you're going to list the 12 part numbers, highest annual usage at the top to the lowest annual usage at the bottom. And the right-hand column on page 13 will help you translate the proper part numbers in sequence, highest to the lowest. Then what you're going to do is actually show the annual usage value from page 13, which is the second column from the right. Again, highest to the lowest. Then you're going to run a cum total. After you run the cum total, you take that cum total and divide it into each one of the cumulative annual usage values above. So that means you're going to do 11 divisions. There you're going to get the cum percentage, which is the second column from the right on page 14. Then by using the guidelines that develop the ABC analyses, which is found on page 16A, you are going to develop which are the A, starting at the top, then followed by the B, and then followed by the C items. Now, when you're complete with page 14, you'll look at page 15, which is a summary page. So all you're going to do in this case is use the first 3 lines. Under classification, the first line is A, the second line is B, and the third line is C. You're going to develop the percentage of items. Let's assume that 3 of the 12 items were A items. 3 divided by 12 is 25%. So therefore, the percentage of items would be 25%. The dollars per classification would come from page 15, and the dollar percentage of classification likewise would come from page 14. So all you have to do is to calculate the percentage of items for the number of A's, B's, and C's, then transfer the dollars per classification over from page 14, and likewise the percentage. And this is an annual report. How frequently should we process the ABC analysis? At least once a year. Some companies will generate an ABC analysis twice a year. If you have items that are constantly being introduced into let's say, into the storeroom and into the inventory system because of the advent of purchasing new assets, new equipment, then you may want to run it twice a year and develop, if you will, what the projected annual usage value would be for items that are new entering into your inventory management system. And now moving on to the next page, on page 16, are the procedures. And I just went through the procedures for you. So I'm not going to read these procedures, but merely indicate that Item 1 addresses the data that you want to consider: part number, description, unit of measure, unit cost, and annual usage. All of that information is available in your inventory record. Item 2 is the multiplication. Item 3 is the ranking, and that's through a sorting process. And that's why it's important to utilize CMMS for this particular application. And after step 3 has been accomplished, step 4 indicates that you're going to count the items, and then you're going to get into a cumulative annual usage value analysis, which is step number 5. And then you're going to divide the individual items' annual usage value by the cumulative, which I mentioned previously, looking at page number 12. And now moving on to page 16A, step number 7 is getting the total count, and we divide that total count by each one of the above. And now step 8 is the development of the individual classifications of A, B, and C. And those classifications are defined below item 8, where A indicates that 20% of the part numbers would represent approximately 80% of the cumulative usage value. And this is important, approximately. You notice from page 12, we had 20% of the part numbers represented by a little over 71%. So this does not mean that I have to have precisely 20% of the part numbers represented by 80% of the annual usage value. The B items, another 20% of the part numbers would represent another 15 to 20% of the cumulative annual usage value. And the C items would be the balance. Now if you turn to 16B, there is the item number 9, or step 9, is considering the ABC classification. And here's where we actually do the identification, which is really that third exhibit that you filled out, the first 3 lines. What are the A's, what are the B's, and what are the C's in terms of percentages of item, percentages of cumulative annual usage value, and percentage of total cost relative to annual usage value. There is also a note on the bottom of page 16B which reflects that if you wanted to use other alpha characters like D, E, and F, then you're going to have to develop your own parameters for A, B, C, D, E, and F as identified on page 16A, item number 8. And moving on now to page 16C, these are some of the byproducts of the ABC analysis, and that is it's used for the input into inventory reduction through vendor stocking. It's the input into cycle counting. It's the input into a vendor lead time analysis program. It is also the input into a priority system where if we had several receipts in the receiving portion of the storeroom, and likewise in receiving inspection, the A's would have the highest priority to get those processed first, followed by the B's, and subsequently the C's. It is also the input into an obsolescence program. Now remember, I said input because anything that has 0 usage multiplied by its unit cost is going to be at the bottom of that ABC analysis. And the key to determine and truly if it is obsolete is to have the spare parts where used list, which we covered in section 3 of this particular program. Now, starting off on page 17 through 17E, we are addressing the cycle counting program. Just like the ABC analysis is an independent sub-software of the inventory management program, cycle counting is another independent sub-program, that is software-wise, to support the cycle counting in the inventory management program. So when you're looking at software, the user-defined requirements should be, does the software have all of the inventory control techniques that we've covered in this section? That would be the first question. The second one, does it have ABC analysis capability? And the third, which we're going to get into, does it have cycle counting capability? And the answer should be yes to all three questions. Now, looking at the top of page 17, we're going to go through the development of the cycle count program. As the first paragraph illustrates, that the cycle count program is a byproduct of the ABC analysis that was covered on pages 16C and 10B, using the byproducts of the ABC system. Now, the second paragraph alludes to the fact that the CPA profession, the Certified Public Accounting profession, has authorized the adoption of cycle counting to replace the physical inventory, providing it is done correctly. And the procedure is as follows, starting off with step 1. We have to generate the ABC analysis, and step 2 indicates that the ABC analysis starts on page 16 of this section. And once we have classified the ABC items, then on step 3, we have the 3 different methods of counting, and they are: for the A items, you must count those a minimum of 4 times a year. The B items, those must be counted a minimum of twice a year, and the C items must be counted a minimum of once a year. Continuing on page 17A, step 4 indicates that prior to starting the cycle count program, you should first take a physical inventory and have all inventory records updated. And then step 5 is extremely important, that storeroom better be secure. If it's not secure, don't start cycle counting. You're going to waste your time and you're going to waste your money. After the storeroom is secure, step 6 indicates that the 4 transactions that you find in a storeroom as receiving, storage by bin location, issues, and consolidations must all be reported accurately. Then you start the cycle count program as indicated by step number 7, and daily you will have on the cycle count form so many A, B, and C items that are going to have to be counted. So cycle counting is a daily minimum of physical inventory. And that depends on how many items are in your storeroom. Some companies can cycle count every other day, like Monday, Wednesday, and Friday. Others can count on a Tuesday and a Thursday. And as the volume dictates, we may have to cycle count every day. The next exhibit on 17B reflects the cycle count form, and the cycle count must be recorded on the form, which is step number 9. Then 10, the cycle count is next, compared to the storeroom record quantity, which is identical to the inventory bin on hand, except if you had 2 or more storerooms, as I indicated earlier, then you're going to have to add the sum of all the cycle counts and then compare it to the total inventory on hand. And step 11 are the parameters of accuracy that cycle counting is looking for. The A items must be 99.5% accurate, that is cycle count to the bin on hand record. The B items must be 99.0% accurate, and the C items should be 95.0% accurate. On step number 12, if the cycle count accuracy is less than that shown in step 11, the cycle count is rejected and it must be done over again until there is either a reconciliation or there must be a record adjustment made to the inventory bin on hand. Continuing on page 17C, step 13 is one of the responsibilities of the cycle counters is to determine what caused the errors if errors are found. Now sometimes this may appear to be a lost cause, but remember, if the storeroom is secure and you're counting and recording those 4 transactions that I just mentioned a minute ago, your errors should almost be 0. It's when you do not establish the disciplines of the storeroom that the inventory record accuracy starts to deteriorate. Step 14 is after count reconciliation, the cycle count form is forwarded to the financial department. This is a legal source document, just like your annual physical inventory cards. Remember, cycle counting is replacing the physical inventory. Item 15 indicates that at the end of the first cycle count year, you may want to take a second inventory. This is really a financial department responsibility. And from that point on, you can maintain the cycle counting program. Now, I do have a note, which is the last paragraph, that we do go into cycle counting in greater detail in our what we call our maintenance stores program, and that is how to organize, manage, and control maintenance stores. And we also have the program number for you in this last paragraph. Now, moving on to page 17D, we are going to develop with you the load of cycle counting in the storeroom. There's always a question, do I have enough manning to take care of cycle counting if it's going to be done every day? And in 99% of the cases, the answer is yes, you have ample time. And I'll just show you how this development of load occurs. First of all, we have on the left-hand column an inventory class code. There's our ABC. Then we have the number of part numbers. So we have 500 A items, 1,500 B, and 3,000 Cs. So we have a total of 5,000 part numbers in this inventory. We're going to multiply that by the annual count frequency. So the A items, we're going to multiply 500 times 4. Remember, 4 times a year. The Bs, 1,500 times 2. And the Cs, 3,000 Cs. Multiply that by 1. That's going to give us the total maximum projected count. Now remember, those items are not on hand all the time. So if I add up the number of items, the second column from the left, we have 5,000 part numbers. And if I look at the right-hand column, that illustrates that we have a projected maximum count of 8,000 items. On page number 17D, we reviewed the process to determine the total number of cycle counts for a specific exhibit. And the data elements that appear on page 17D are shown in this particular screen format, and likewise, if you would look at the notebook, page 17D1, though that would be identical to the screen format that you are now reviewing. We indicated that we had 5,000 A items, 1,500 B items, and 3,000 C items. We multiplied that by their individual minimum count frequencies, which is 4 times a year for the A items, twice a year for the B items, and then once a year for the C items. And looking at the right-hand column, we have the extension, which again is identical to the extension shown on page 17D in the notebook. And that provides us with a total annual projected count of 8,000 part numbers. Now you'll notice when we get back into the notebook, we're going to take those 8,000 counts, divide that by the number of working days per year, and then that will project the number of items that we're going to count in total as a byproduct of the cycle count program. And then we're going to do the same thing with the number of total counts for the A, the B, and the C items, and that will provide the maximum counts per day for the A, B, and C items. And those calculations are following page number 17D in the notebook. But what we're trying to do here with this particular screen capture is to show you that you can put all of the data elements into what I call the cycle count frequency calculation software, let it do all of the work for you, and therefore you are now in a position to identify those part numbers that are A, those that are B, and those that are C, and based upon the development of instructions relative to inserting the A, B, and C codes into each individual part number item master record within the inventory management system. The software will do all of the work for you, and now it's a question of merely instituting the cycle count program. Now moving on to the daily cycle count workload, we're going to utilize the formula that's shown on the left-hand top portion of 17E, and it says the daily count is equal to the total annual count divided by the number of working days. So we have 8,000 maximum count, and in this case we're assuming we're working 50 weeks a year, 5 days per week, or a total complement of 250 working days. And if I divide 250 into 8,000, that means we're going to cycle count 32 items per day. If we look at the bottom portion, we develop the workload for the A, the B, and the C items accordingly. And you could see if we were to, let's say, allow 5 minutes for each item that we're going to cycle count. If I took 32 and multiplied that by 5, that would give me 160 minutes. If I divided that by 60, that is what? That is a little more than 2 hours. So therefore, the cycle count program is not a full-time job, but it must be done daily. But remember also that 32 items per day in this illustration represents all of the part numbers that are supposed to be counted every day. And if the inventory management program is working properly, and if planning and scheduling is working properly, you're not going to have 32 items every day to count. You probably may only have 5 to 8 items per day to count. That is 5 to 8 items that are actually been on hand. So that is the basic requirement for the development of the workload for cycle counting. Now we want to finalize both the ABC analysis and cycle counting by looking at page number 18, headed Byproducts of the ABC analysis. The first one indicates that we have been able to identify A, B, C. Second, it's the input into cycle counting. We've just gone through that example. 3, it's the input into inventory investment reduction, and that we will take a look at shortly. It's the input into a supplier lead time analysis. In other words, critical A's, B's, and C items should be reviewed maybe every other week, but no less than once a month with vendors. Item number 5 is the input into a priority program that I have previously defined. And then 6, it's the input into an obsolescence program. Now, item 7, some people ask me, Frank, can we lay out the storeroom by ABC code? The answer is no. You lay out the storeroom by the commodity or family code, and those are items that we're going to discuss when we get into the storeroom program. Now, commencing on page number 19 through page 30, we have several exhibits here to support how some of these inventory management applications were actually derived. So if you will, look at page 19. There's the formula, and there are the data elements that are within the formula. Now, we know that A is our annual usage value. We know that C is the item cost. We also know that S is either the ordering or the setup cost. So what we really have to do is to determine how was that ordering cost developed, and I, the carrying cost, really what goes into the carrying cost. But most importantly, where did the EOQ formula come from, including that square root sign and that value number 2. So if you would turn to the next page, we're going to look at the data elements that go into carrying cost. First of all of this data should be supplied to you from your financial department. They really should give you the carrying cost, as I indicated before. But the data elements that comprise the carrying cost is the insurance you pay for your assets called inventory, the taxes on the inventory assets, the obsolescence cost if you truly have an obsolescence program, the cost of capital, which is the cost of borrowing with any percentage points, and the cost of storage. Now, all of these cost on an annual basis, and most companies represents approximately 20% per dollar per year. The way to look at it is if I have $100,000 in inventory at 20% carrying cost, it's costing me $20,000 a year to carry that inventory. Reduce that inventory by $80,000. That's 80% of $100,000. That means $80,000 times 20%, I am saving $16,000 a year, and that's an annual savings. I wonder how many CMMS programs you could purchase with $16,000. That's one of the key paybacks that will support, financially speaking, CMMS. Turning on to the next exhibit, we have the purchase order cost. And again, these are annually. We have the purchasing department expenses, and that includes payroll, overhead, and every other cost associated with the purchasing department. Likewise, receiving and receiving inspection. And if any of the above three are utilizing any data processing applications, then those costs should likewise be prorated over the 3 above costs. Now, if I total all of those annual costs up and divide by the number of purchase orders I'm going to issue in 1 year, I will get what is called my average purchase order cost. Now, you'll also notice on this page and the previous page, we have kind of a little fulcrum on the top with a couple scales. What those scales in that fulcrum is indicating is when the carrying cost, okay, which is on page 20, is equal to the purchase order cost, which is on page 21, when those costs are equal to one another, that is the most economical purchased quantity. Now, if we go over to page number 22, we're going to show you how those costs actually were utilized to derive the EOQ formula. Now, in order to accomplish this, what I've done is I've taken one item that had an annual usage value of $1,200, identical to the annual usage value that you would use in an ABC analysis, and we have S, which is the purchase order cost, in this case $1, and I, the carrying cost of 10%, to make it easy to go through this illustration. Now, looking at the body of page number 22 and starting at the left-hand side, we've selected 5 different frequencies of purchase: semi-annually, quarterly, bi-monthly, monthly, and semi-monthly. Those frequencies of purchase are identified by the third column from the right, called or headed number orders. Now, taking that column number of orders and dividing it into the $1,200 of annual usage, we get the second column from the left called OQ, and that is order quantity. So 2 into $1,200 is $600, and 4 into $1,200 is $300, and so forth. So the OQ goes from $600 all the way down to $50 in terms of order quantity. Average inventory is 1/2 the order quantity. So I take that second column from the left, OQ, I divide those figures by 2, and I get the average inventory. So if I took $600 and divided it by 2, I would get $300. Take $300, divide that by 2, I get $150, and so on. Now, the carrying cost is always calculated by the average inventory times the carrying cost value. So in this case, looking at the semi-annual frequency, I have $300 of average inventory. We have a carrying cost of 10%. And remember, change that percentage into its decimal equivalent when you're going into mathematical computations. So I have $300 times 0.10, or a carrying cost of $30, and subsequently down, going through the same type of computation. If I look at the second column from the right, the purchasing cost, I take the number of purchase orders that are reflected in the third column from the right under number of orders, and I multiply that by $1 per order, and I get the purchasing cost, which reflects $2 for the semi-annually and all the way down to $24 for the semi-monthly frequency of purchasing. Now, the total cost column on the right-hand side is developed by taking the carrying cost column and adding that to the purchase order cost column. So the fourth column from the right added to the second column from the right gives us the total cost. Now, you're going to notice as you peruse down the total cost column, starting off with $32, then it drops to $19. It further drops to $16. Now, the reason for that, if you look over on the carrying cost column, the carrying cost is starting to decrease. But as I increase the frequency more and more, the total cost starts to swing upwards, where I go from $16 to $17, and then I go from $17 to $26.50. So it appears that the most economical method of purchasing this item would be bi-monthly, 6 times a year. Now, the EOQ formula actually was derived from the plotting of the carrying cost, the purchasing cost, and the total cost. And those cost figures are, I should say the graph for those cost figures is on the next exhibit, called the combination of annual cost on the left-hand vertical column to the number of orders per year on the horizontal column. Now, let me at least address the three curves for you. The acquisition cost, starting off at the apex of those two vertical and the horizontal lines moving upward to the right, is entitled acquisition cost. Cost to acquire. There are two costs to acquire. One is the purchase order cost. The other one is the setup cost if we manufacture the part. That's a straight line. Now, the maintenance cost, which is that lower curve, is another term for carrying cost. And that comes from a high carrying cost where we have a low number of orders but high average inventory, to where we start to actually get into smaller lot sizes, smaller average inventories, and therefore smaller carrying cost. Where the acquisition cost intersects the maintenance or carrying cost is the lowest cost. So if we took that total cost column that was on the right-hand column on the preceding page and we plotted that, we would actually get that total cost curve, which is the sum of acquisition and maintenance costs. Now, the straight line, the acquisition cost, has a formula. The unknown is order quantity. The maintenance cost, the geometric curve, likewise has a formula. The unknown is the order quantity. When I set those two costs equal to one another, like the balancing scale, but in this case I want to solve for the order quantity, we go through some iterations and we actually get the formula for the total cost curve. Therefore, that total cost curve is the EOQ curve. And that is actually how the EOQ formula was derived. It was derived mathematically, and the EOQ formula is a financial analysis. It is comparing the cost to acquire versus the cost to carry. When those two costs are equal to one another, remember the fulcrum with the balancing scale we looked at previously, when those two costs are equal to one another, that's the most economical order quantity. Now, moving forward to page 24, we're looking at the order point formula. Now, the order point is equal to some type of usage times the lead time plus a safety factor times mean absolute deviation. What type of usage are we actually talking about? We're talking about the average usage over many periods of lead time. So what I want you to do is write the word average in front of the term usage. Now, if you turn the page, we're going to take a look at an order point graph. And let me address some of the data on this particular graph for you. Looking at that vertical line on the left-hand top where it reaches an apex and it starts to come down, that line is called inventory on hand. If you were to take that order point where all of those usage lines disseminate right below the term OP, which is order point, and draw a dotted line over to the bin on hand, that would be the point that you would order. So order point is a pre-calculated inventory level on hand where I would order. Those different usage lines cascading from the order point going from left to right shows us that we have some low usage periods which are in the top portion. We have two that go into safety stock. They actually use safety stock. Those are called high usage periods. And then there's that one line that goes slightly below safety stock. In other words, we had a stock out, and that I call extremely high usage period. So that vertical line that addresses average inventory from order point down to the safety stock is where we develop the average usage times the lead time, which is expressed horizontally from that safety stock little arrow over to the point of where now we have another vertical line that's coming up, and that vertical line has two titles to it. It's called bin on hand plus lot received or purchase order received. And the bottom portion is the safety stock. So this illustration here is tying together the formula for the order point. It's equal to the average usage times the lead time plus safety stock. And safety stock, if you remember, is derived from mean absolute deviation times the safety factor from a table of safety factors and service levels. So if you turn to the next page, we're looking at a service percentage and what we call inventory investment in thousands of dollars, which represents safety stock. So this curve that you're looking at, which curves up from left to right, is a safety stock service level curve. And you notice as we move to the right based upon service percentage, which is another term for service level, the safety stock starts to go up geometrically. And that curve is a byproduct of the multiplier that has been assigned to various service levels that are on the horizontal level of this particular exhibit. So if you would turn now to page 27, and if you remember, I made reference to this page several times earlier. We have two columns here. The left-hand column is the service level column, and it goes from 50% up to 99.99%. That's telling us that statistically you can never have 100% service on a continual basis. There's always going to be either an unplanned order or an unplanned requirement, or the vendor may not ship within the lead time that is specified in the order point formula. The column on the right-hand side is headed MAD, but that is not mean absolute deviation. Up on the top we have a heading that says Table of Safety Factors for Normal Distribution under the mean absolute deviation application. And if you remember, on one of the exhibits that we actually went through a calculation, we said we had a service level of 95%. So if you go down the left-hand column to 95%, and then you read across, there's the safety factor that we used of 2.06. So there is a correlation between the service level and the safety factor, which really was developed on page number 26, which was the service level safety stock curve. Now, we previously indicated in section number 3 of the notebook that we were going to tie together the where use code, that's the numeric code, with a service level, with a safety factor, and the calculation of mean absolute deviation. So if you turn to page number 28, we have this service level matrix for you. And let me identify the interpretation, please. The where use code is on the left-hand column. That means if I have a where use code of 1 to 3, most companies are selecting a service level of 95%. they're not going to go below 95%. The safety factor for 95% from the previous exhibit, page 27, is 2.06. Now we go to the next where-use code, which has a range of 4 to 6. There's a 96% service level, and that safety factor is 2.19 and so forth. So this is a matrix that has been developed through experience dealing with many companies that are calculating the amount of inventory we want to have been on hand for future unplanned requirements. Now you notice there's a notation which takes a moment to analyze, and I'd like to do that for you at this point in time. It talks about the service levels as a function of actual experience for each machine or asset and its spare parts historical usage pattern, and the degree of management's accepted machine asset hours of productivity. Let me indicate one of the key considerations when this particular matrix is being used. If a predetermined, let's say PM activity, is supposed to be done every 90 days, and that 90 days is demonstrated by the PM requirement of the supplier of the equipment. And let's say that that 90-day period is for normal operation of that asset, one shift, 40 hours a week. That means that if operations went to 2 shifts, and therefore we went to 80 hours a week, then that service level code of 90 days, or the frequency code of 90 days, is going to have to be changed to 45 days. And subsequently, if I went to a 3-shift operation, I would have to reduce that 45 days down to 30 days. On the other hand, if I went from 3 shifts to 2 shifts, I'd have to likewise reduce the frequency. And if I went from 2 shifts to 1 shift, I would also have to reduce the frequency. If you don't change the frequency code when the operations schedule changes, and if frequency is to be changed, I'll guarantee you're going to start to have machine failures. And therefore, all the work that we're putting into the development of safety stock for future unplanned requirements is going to start to fall by the wayside. So remember, these where-use codes, the service levels, are a function of average usage of an asset predicated upon the OEM's maintenance requirements. Then you must change those frequencies accordingly if you want to maintain the level of inventory under a well-planned and managed environment. Now, moving on to the next exhibit, page number 29, we're going to talk about the min-max system. There are some basic requirements for the min-max system. Number 1, the lead time must be immediate. Number 2, usage must be constant. If I use 1 a month, that's constant usage. Step 3 is the establishment of safety stock. That's the minimum. If a vendor is across the street, or let's say within several hours of transportation time, I could get by with a minimum of 0. And I would feel very comfortable to release let's say a requirement to the supplier and have it delivered within 2 to 4 hours. However, if the vendor requires some additional transit time, then that means that the minimum should be raised. There is no formula that I know of that indicates what that minimum should be. It's a little bit of common sense and experience with the supplier. Therefore, we have an opportunity to establish the minimums under the min-max system, whether the minimum is 0 or it's equal to or greater than 1 by using some criteria. That criteria should be defined, just like the criteria that we are looking at on page number 29. That pertains, what I've just gone through pertains to item number 4. Then the difference between the max minus the min is the calculation of the order quantity. Now I know that there are many software programs that are out in the marketplace, and the only thing they offer you is a min-max system. That to me is an antiquated system, because min-max does not take into consideration average usage. There's no indication of the actual aggregate lead time of the item, and we are also not tracking vendor performance relative to on-time delivery. So it is extremely important to know when to use the min-max system. It is a good application for, let's say, the bench stock program. It's a good application for, let's say, inventory class code item number 1. It's a good application for vendor stocking programs, providing the vendor is going to guarantee that they will carry an X quantity for you. It has applicability, but it is the wrong criteria to use, or the wrong technique to use, for all items in the entire inventory system. Now, turning to the next page, there is a graphic representation that represents what the D, the deviation below the min, is. We're showing two different usage patterns here. The first one, we've gone a little further below the minimum as we have on the second one, which is on the right-hand side of this particular illustration. The key to remember, if the minimum is equal to or greater than 1, then you have to add the deviation below the minimum. And you'll notice that I have indicated in the bottom portion below the minimum that arrow entitled safety stock. Now that's not safety stock as we have developed safety stock in the order point system. That is protection stock based upon your experience and also how critical the item may be relative to future unplanned requirements. Moving to the next example on page 31, we have 3 pages here, 31, 32, and 33, that addresses the bench stock or the 2-bin system, and the procedures are identified on 31 and 32. These are the items that are going to be carried in your maintenance repair shop. Step 1 is we establish the part numbers. Step 2 is we're going to establish how much inventory we may want to carry in the repair shop. My recommendation is try not to go over a 30-day supply. If items are bulky, like let's say some piping items, T's and elbows, you may want to consider a 15-day supply. After all, the storeroom is going to be responsible to replenish the inventory. The term 2-bin means that some inventory is going to be housed in a repair shop, but the balance of the inventory, the major portion, is going to be retained in the storeroom. Step 3 is establish the physical location of where the items are going to be physically housed in the storeroom. And then we want to establish the work in process location by, let's say, bin number, or if we have a carousel, by tier number within a carousel, or any other storage requirement. We want to establish the requisitioning system. Well, there is no requisitioning system. The storeroom will actually be responsible to replenish the inventory through one of 3 methods, which I will explain in a moment. Now, moving on to page 33, item number 6 indicates that we want to test the system, so we're going to track the usage. We're going to develop the replenishment quantities, and those could be changed based upon the actual usage pattern. And that usage pattern is actually recorded on the inventory record by part number. We're going to make certain that we're tracking the vendor lead times, because again, we're going to use maybe a min-max system for these bench stock items, and then we're going to revise the bench stock quantities, like I said a moment ago, as required. Now, the form on page 33 is a very typical 2-bin replenishment form. And let me identify how this is used, and I said there are 3 different applications for this. First of all, this is Tier 5 for rotary bin 5 in the mechanical department. And on the left-hand column, we have the part numbers, we have the description moving to the right, and then we have the actual quantity that is going to be stored originally, and we're going to use that same quantity as the replenishment quantity. Now, that right-hand column, all it requires is a check mark or some type of notation, a star, in terms of the part number that has to be replaced. How do we know that that part number is going to be replaced? Let's talk about 3 approaches to this particular item. First of all, if I'm in a manual environment, then I'm going to have to physically go out to the storeroom with, let's say, not a storeroom, but the repair shop, to its location with a clipboard and the part numbers that are an integral part, in this case, of the mechanical repair shop. The individual that's doing this works in the storeroom. He or she will physically eyeball, that is, use your eyes to determine whether parts should be replenished or not. It's a judgment call. If you feel that there's sufficient quantity for another week or so, then don't worry about replenishing it. If it looks like we have used some, I would put a check mark next to that part number and put check marks next to all of the part numbers where the inventory has to be replenished. Now, manually, I go into the storeroom, I pick the items from the area called the 2-bin section, where 2-bin items are going to be stored, and they're going to be stored by type of repair shop, one for mechanical, one for electrical, maybe one for the carpentry shop, and so forth. I actually pick the box that has been pre-packed according to the quantity on the pick list. Then I will go to the inventory record and show the issue of 25 pieces. In this case, all of these are 25. And I physically go out and put the items right into the bin or the carousel or a tote pan, or however that material is physically being housed in the repair shop. The same 25 pieces that was issued out of the storeroom likewise has to be communicated to the inventory record as a usage and as a deduction against bin on hand. Now, if I'm in a computerized environment, I still would require a document like we have on page 33. I do the check mark, I do my eyeballing again, but in this case, rather than go in to, let's say, a manual tub card file, I would use the keyboard, I would enter the part number, enter the quantity. It will automatically update both the store bin on hand and the inventory system, and it could likewise print out for me only those part numbers that now have to be pulled from the storeroom and then brought over to the various repair shops. Now, that's the second method. If I barcoded the identification tags in the repair shop, I can go out with a handheld wand and merely wand the barcode label for the parts that are to be replenished. and then I would take that handheld wand and I could put it into a port, into, let's say, a PC or a terminal, and I could upload those requirements directly into the storeroom CMMS. It would print out the pick ticket for those items that I require. It would also update the storeroom bin on hand. It would update the inventory record, and I merely withdraw the materials, get them out to the various repair shop locations, and I'm through with supporting the two-bin system. There's just one consideration, and that is, since we are pre-packaging parts into a pre-packaged quantity, you may want to consider using what I call the recycling procedure by taking those boxes. Maybe they could be folded down flat and returned to the supplier, go through the reordering, the replenishment for the storeroom, and save the cost of the carton. That should be worked out between you and the supplier. So page number 33 is the document that is required to support the two-bin system. As I reviewed the two-bin system for the mechanical department on page number 33 and indicated that there are different approaches in which we wanted to support the two-bin system or the bench stock program utilizing data processing applications. Well, on this particular screen capture, and incidentally that is page number 33-1 in the notebook, this would be a printout for the roto bin number 5, tier 5, the various part numbers with their description and the quantities that have been predetermined to support the mechanical department for those particular part numbers. You'll notice on the right-hand column, just like we discussed on page number 33, we place a check mark or an X indicating that those items should be replenished when an individual from maintenance stores reviews the individual roto bins that are in the mechanical shop. Now this would require, as an example, for any item that was marked with a check or an X, that we would update the issue of that quantity by part number to the mechanical department. So we keep our inventory records 100% perfect. On the other hand, as I indicated, we could go into barcoding and eliminate this particular document. So again, we're just trying to show you that these various inventory management applications that we have been discussing and reviewing with you, that you can put those into a viable CMMS application. Now moving on to page 34, we are showing what we call a decentralized storeroom location, and that little storeroom is supporting 4 different manufacturing departments. Those department numbers are identified in this particular exhibit. The parts that are in that storeroom are generally used exclusively by these 4 departments. They are not motors and gear reducers and items of high value. They could be many C items and some Bs. There should be a computer printout of part number, description, unit of measure, the bin location within that decentralized storeroom, and then the quantity on hand. To the right of that quantity on hand, there should be a column to show issues. All the craft person has to do that's going to service those areas is indicate the quantity issued and that cost of that part can be distributed as overhead relative to the maintenance of those 4 departments. Or if you wanted to, you could include another column which would indicate the maintenance work order number, and then that document would be picked up by storeroom personnel on a periodic schedule basis, and it would also have its own replenishment cycle similar to the 2-bin system. It's a way to provide low-cost items that are quite frequently used, and to support not only the planned maintenance work order program, but also the unplanned maintenance work order program. Now, moving on to page 35, we have 2 different examples that we want to address relative to a minimum order quantity, or what we call a number of days supply. And here's how it works. We're given that we're going to look out 20 days into the future. So we're looking at a 20-day supply period. Therefore, that means that this is part of a planning process. We were also told by purchasing that the minimum order quantity is 2,000 pieces. Now let's take a look at 2 scenarios to determine whether we got the right info from purchasing or not. Under the first scenario, looking out 20 days into the future, we have a requirement of 1,795 pieces. And we recognize that 2,000 is the minimum, so we're going to purchase 2,000, and we would retain in inventory in the storeroom 205 pieces. And if you remember from our inventory classification code, we do have a code for vendor minimums, and likewise have a code for vendor unit packs. That is the excess that cannot be used at the point of purchase and applied against either a planned or an unplanned order. Now the second scenario indicates for another 20-day horizon, we have a requirement of 2,365 pieces. Since 2,000 is the minimum, we order 2,365. But guess what? We get a phone call from the supplier. And the supplier says, you made a mistake. You should have ordered 4,000. Now, what's the difference between 4,000 and the minimum of 2,365? And here's the difference, and here's what I'd like to have you write down at the bottom of page number 35. And it goes very simply. Is 2,000 the vendor minimum or the vendor unit pack? In this case, purchasing did not ask that question. They assumed because someone at the supply base says, yes, it's a 2,000 minimum, where they should have said, yes, it's a 2,000 unit pack. So in the second scenario, we actually should have ordered 4,000 pieces. I know this seems rather mundane, but this has really put some of my clients into an awkward position with the supplier because their inventory management system was not coded properly. Don't be afraid to ask the supplier that simple question. Is 2,000 a minimum or is it a unit pack? And you'll prevent all kinds of problems between the vendor and you, and likewise you're going to reduce the lead time when you really need parts against planned requirements. Now the next page addresses the supplier minimums, and there are 4 steps involved. And the first step is that the minimum is established by the supplier, and the supplier minimum may also be a supplier unit pack. It is conceivable, it could be both. And step 3, it's the purchasing's department responsibility to ask that question. Is it a minimum or is it a unit pack? It is also the purchasing department responsibility to convey this information to the inventory management program. Now moving on to the next page on 37, supplier unit packs. We basically have another series of steps to make certain that we're getting the right information into the individual part number item master record. The first step indicates that the supplier establishes the unit pack. Secondly, the unit pack indicates that there are X quantity in a unit pack, a drum, a reel. That could pertain to a conversion if it's other than units of eaches or pieces. Item 3, the purchasing system must have the capability to convert the unit pack to a quantity per package, especially if you have a master carton with inner packs. And fourth, we have the receiving function should count the number of packs received. Also receiving should spot check the quantities in each unit pack. And sixth, when material is placed in stores, the store system must have the capability to convert the unit pack to actual quantity received in order to reflect the actual quantity, what I refer to as bin on hand. So these two exhibits, page 36 and 37, addresses the derivation of the minimum and the unit pack, and it also provides you with the procedures that you should really put in place. Now, the next 4 pages, starting off on page 38 and ending up on page 41, addresses the vendor stocking program. Now, one of the byproducts of the ABC system, if you remember, is the input into vendor stocking. So let's conclude now, if you will, the development of vendor stocking, and then we would have identified how cycle counting is used as a byproduct of the ABC analysis, and likewise the vendor stocking program. First of all, item 1 illustrates that we have to establish the part number, and secondly, we establish the annual usage. That is, take the annual usage for all items that are going to be part of the vendor stocking program by vendor now, not in total, but by vendor. Number 3, we're going to get the actual cost of the item, and we're going to go through the extension, and we're going to develop what is called the annual usage value. Now, if an item is supercritical, if there's high volume involved, then step 4 says that you may want to select 2 suppliers. If you do select 2 suppliers, try and have an even split between your annual requirements, like 50-50 or 45-50%, but try not to get into percentages like 30 and 70 and so forth. Try and split the business as equitably and fairly as practical. Item number 5 indicates that you negotiate the supplier stocking benefits with the supplier, including the annual discounts, let's say based upon various annual purchasing dollars. Now, if you have all the part numbers, you got the quantity, you got the unit cost, you go through your extension, then you summarize it, you'll have the total dollars that you need in step number 5 when you sit down and talk to the supplier. Moving on to the next exhibit, we want to establish the reorder criteria for all items. Now, you probably, as I said before, may want to use a min-max system for vendor stocking items. But the other thing that you have to make certain of is the development of the minimum quantity that the supplier is going to carry for you. So there are 2 types of inventory that you want to establish. That is your reordering strategy and the vendor's quantity that he or she should never go below as an integral part of this type of a program. Then item 7 is to establish the lead times, because that is going to help you to subjectively develop your mins and max in your reordering strategy. Then what you want to do is item number 9 indicates that you want to develop the necessary data processing hardware and the telephone communications or the telephone communication equipment for the program. And basically, this type of a vendor stocking would be where we carry some of the inventory and the vendor likewise carries some of the inventory. The hardware requirements are very simple. You need a terminal, you need a modem, and you need a telephone. And basically what you're doing, that is done by the storeroom, is when items are to be replenished from a particular supplier, you dial up the supplier's phone number, which gives you access directly into the supplier's mainframe. You will be looking at maybe some security codes, which is item number 10. And once you go through your security code development, then you will actually see the menu of what the supplier has on hand by not only his part number, but by your part number, the bin location, and also the minimum quantity that he or she is supposed to carry for you on hand. There's one column on the right-hand side which indicates quantity to be ordered. And that's where your cursor lies, strictly on that right-hand column. And the person in the storeroom merely indicates the quantity to be ordered, and that is actually put in through the terminal, and it actually is keyed into the supplier's mainframe. And when you are through with entering your various quantity ordering requirements, you hit enter, and at the supplier's place of business is printed out a 5 or a 6-part purchase order form, which is your purchase order form. And let's say a copy goes to your purchasing department, a copy goes to inventory management, a copy is used for the packing slip, a copy can go to your accounting department relative to accounts payable, and other copies can be distributed internally at the supplier. Now, they pick, pack, and ship. Now, just think about the activities that I had indicated and where the savings are to both you and the supplier. Before we do that, I want to finish the last 2 elements on page number 39, which is test the system and implement the system. Now, let's turn to the next page, where 40 is we're monitoring the system, and then we're going to make any changes that are required, and most changes would have to do with quantities or where we have new items and we want to add those to the vendor stocking program. Now, the next page on 41 lists the benefits of a supplier stocking program. There's got to be benefits to you, and there has to be benefits to the supplier. Now, let's talk about the benefits to the supplier. First of all, number 1, eliminate interviewing sales representatives. You've got that system set up for 1 full year. Number 2, you don't have to generate any purchase orders. The ordering is being done through the terminal in the storeroom. Eliminate, processing supplier quotations. Now, if you have new items, you probably would have to process a quotation request. Reduce purchase order processing time. Absolutely. Eliminate expediting suppliers. Once you query into the supplier's mainframe, you know specifically what he or she has been on hand, and automatically you would know if there's going to be a shortage or a back order. A reduced inventory carrying cost to you, yes. But what about the carrying cost to the supplier? Yes, there's going to be some added carrying cost to the supplier. The supplier is going to carry some additional inventory for you. But what is the supplier's benefit? Number one, you bypassed his or her order entry. You've automatically eliminated credit checking. You eliminated the supplier to create shipping documents. You eliminated the supplier from updating their inventory record. How was all that accomplished? By the person in your storeroom that did the actual ordering. Remember, you updated the inventory record as their record as a byproduct of ordering items from them. You automatically updated their accounts receivable. You generated an invoice for them, and you've updated other financial records. Guess what? Those are tremendous financial savings by the supplier. But most importantly, that salesman doesn't have to call on you anymore, which is another key financial return on the investment of establishing a vendor stocking program. And 7, you're going to reduce storage cost because you're going to have less inventory on hand and to be able to have a higher turnover. The vendor stocking program is one of the key byproducts of not only the ABC analysis, but it must be supported by work order planning and scheduling. Remember, we're talking about reducing inventory by planning and scheduling, number 1, and number 2, by reducing inventory through the vendor stocking program. And I know once you have gone through this, many of your items are going to be ordered through vendor stocking, at least those items where you have repetitive usage. Now, the last 4 pages in this section pertains to JIT, just in time. The following data elements must be functional before JIT will work. And these can be accomplished. There's nothing in here that cannot be done by you, providing you have the proper software, CMMS. You've got the disciplines of the lead times, the disciplines of the storeroom, the proper inventory management program supported by purchasing. So let's take a look at these data elements. The first one is to have spare parts list complete and accurate. That is for all assets. Well, you should have that anyway, even if you don't go into JIT. The spare parts where used list is complete and accurate. You need that where you're trying to eliminate obsolescence in the storeroom. 3, the total lead time for all JIT items is defined and accurate. Remember, all JIT items. That means that there are some items that are not candidates for JIT. Some hardware items, O-rings, and other could be high volume but low expensive items. So all items are not going to be candidates for JIT. 4, the suppliers have a thorough understanding of their requirements to support JIT. 5, supplier quality problems do not exist. That's why you have to establish a vendor analysis or appraisal program. It takes 1 year to implement that. We'll talk about that when we get into the next section, Section 5 in purchasing. And then you're going to ultimately certify the vendor based upon his or her highest quality. And item 6 is the quantities that you're receiving are accurate. And item 7, the due dates are met 100%. Those are the key basic criteria, not only to give certification, but to support JIT. Item 8, The maintenance work order scheduling system is scheduling both planned and unplanned maintenance work orders. And item number 9, the maintenance inventory control system is recording both planned and unplanned requirements. Well, you should be doing 8 and 9 automatically once you start implementing the PM program, and then subsequently the minor and then the major overhaul programs. The 10, the special tools and equipment for the maintenance work order program are known and available. And 11, craft personnel requirements are known and available. They're known through planning, and then when you schedule them, you'll know that they're going to be available. And on the next exhibit, item number 12 is addressing that the storeroom has a defined area to house unplanned maintenance work orders as well as planned. Item 13, the maintenance work order scheduling system is interfaced with the manufacturing work order scheduling system and the maintenance purchase order system. In other words, they're totally commingled with each other. This is accomplished through CMMS, the integration of the various modules. 14, the equipment asset will be available as scheduled by the maintenance work order system. When you do that, you're going to be world class. That is world class in my book. 15, the maintenance work order reporting system is accurate and timely. How? Through proper training of your craft personnel. 16, changes can be made to the JIT program at any point in time without upsetting the program itself. In other words, they can be implemented with ease. And the last page, 45, addresses number 17. The maintenance JIT program has total top management support. How do you get that? By training from the top down. And 18, the last item in the JIT program, is the maintenance management and manufacturing management have both contributed to the design, the training, and the implementation of the maintenance JIT program. When you look at these 18 items, they are no different in my mind with respect to having those 18 items in place once you have finalized the implementation of the PM program associated with the major and minor overhauls, and probably have introduced some maintenance requirements through the development of the various applications, such as the participation of machine operators through predictive maintenance applications. Many companies have succeeded in accomplishing this task, and as far as I'm concerned, they are no smarter than you are, but they probably have done planning and scheduling prior to maybe your planning and scheduling program. So that concludes section number 4, inventory management. And as I said a moment ago, we will now go to section 5, which is the purchasing management program. Now the first page in section number 5 addresses the basic function of the module, which is really the purchasing section. And if you recall from pages either 3 or 4 in section 1, the module for purchasing is function or module 4 within the maintenance management program. Now, looking at some of the data elements that are on the first page in this section addresses some of the basic requirements of the purchasing function. The first paragraph addresses the primary responsibility of purchasing, and that is to purchase, in addition to assets, the various spare parts and all other related materials that may be required by the maintenance department to support those assets through the maintenance program. The second paragraph pertains to the development of vendor stocking programs. And as we looked at the vendor stocking program in the previous section, section 4, the vendor stocking program is first generated as a byproduct of the ABC analysis. The various items are selected, and then it is up to purchasing to support the vendor stocking program with the various vendor base. The third activity has to do with the vendor performance or rating program. And this is basically how we would establish the various items within the appraisal or performance program and ultimately move into vendor certification. We will discuss all of these issues in this particular section. Now, the fourth paragraph addresses the interrelationship between the maintenance work order planning and scheduling system and the purchase order planning and scheduling system. And as I've indicated earlier in this seminar, where we have maintenance work orders that are planned and we issue purchase orders for those specific planned maintenance work orders, we're going to cross-reference the purchase order number to the maintenance work order number and cross-reference the maintenance work order number to the purchase order number. And this provides the closed loop of information between the maintenance work order planning and scheduling system, the inventory system, and the procurement system. And the last paragraph addresses the shelf life code issue, which we've discussed several times in previous sections, and we will review how the shelf life coding program is established, how it is monitored, and how it is maintained. Now, moving on to the next 4 pages. These are the record layouts for the purchasing function within CMMS. Now, again, these are record layout data elements that we're providing you with. I'm not going to take the time to read these. This is something that you're going to have to peruse through and ultimately select the items that you want to have in your own purchasing item master record. But before we get into the body of the notebook in this particular section, let's address how these data elements are to be read. They're identical in nature to the previous record layouts in the previous sections. Item A is the item number, and we're using alpha in this case, and item A pertains to the vendor number. And in this case, we're recommending a 6-digit numeric number. That number is assigned by the purchasing department. Now again, these are only recommendations. These are not cast in concrete. So therefore, you could develop your own vendor numbering scheme. I'll address the next one with you, and that is item B is the vendor name. And in here, we're indicating you may want to consider a 30-digit record layout, and again, that could be alphanumeric. And that is the way that we want you to look at the data on these 4 individual record layout documents. It's up to you to define your requirements. Remember, The first major element of CMMS, user-defined. So we're giving you the opportunity as a user of CMMS to define your specific data elements. Now, moving into the notebook, into actually page number 1, we're going to address some of the key issues relative to data elements that you should consider in the purchasing system. As an example, item A indicates the spare part number. B is the description of the spare part. C is the unit of measure. Now, this unit of measure is the unit of procurement. Remember when we discussed potential receiving and conversions from a receipt from a supplier going into the storeroom? Well, C is the unit of measure relative to the unit of procurement. And we basically would require conversion capability if this unit of measure is different than that which appears on the asset and its associated spare part list. Item D are the purchase costs of the item. And you notice that's plural, and that is based upon having more than one supplier for one item. We also have item E are the lead times. And again, it's plural because you may have more than one supplier and the lead times could vary. F is supplier information. And a lot of that supplier information is actually identified on the first 4 sheets that precede this particular page, page 1. We have open purchase orders, which is item G, and H would be open requisitions, and then I would be supplier stocking programs, and where we would have more than one facility, and let's say a medium or large size company where we want to pool our purchasing requirements, then J would represent corporate procurement programs. But in order to make that a successful corporate procurement program, as I mentioned earlier, you're going to have the same part number used by the 2 or more facilities that are going to support corporate procurement. K is the supplier performance report, and like I said earlier, we're going to review the data elements that comprise it, walk you through how you would develop it, and that really would be the input into a vendor certification program. Now again, the last item, L, represents additional information that you may want to define in the purchasing activity. Now we just reviewed the data that is required in the purchasing module relative to supporting purchasing with various data elements. And that was reviewed with you on page number 1. We likewise have the screen capture identified as page 1-1 in your notebook. The data that you see in front of you is the same data that we addressed while reviewing page number 1. The screen capture in this particular exhibit addresses a specific part number, its description, and the unit of measure. And again, I want to make reference to the unit of measure. This is the unit of measure that is purchased, not the unit of measure as it appears in the inventory item master record or the unit of measure that appears in the spare parts list for a particular asset or equipment. You'll notice where we have lead times, which is plural, and we have purchase costs, which are plural. We're just showing one box for each of those. We actually, if we had more than one supplier with different lead times and different purchase costs, we would have individual boxes for the individual suppliers, and those suppliers would be identified not necessarily by supplier name, but let's say by supplier number that was assigned by the purchasing personnel supporting purchasing in the maintenance management program. The other data is self-explanatory, and again, you'll notice that you have the option to pick and choose to format these particular screen captures to meet your own specific requirements. And again, I want to make a comment that I have made several times in the past. You want to tailor these to your requirements. So pick and choose and then select the appropriate data from the data that appears in a notebook, and along with any additional information that I have always alluded to, that no specific listing of information is ever complete. You add the additional data, format the screen according to your own requirements, and then the individual software supplier should provide you with the format that you are requiring. Now, moving on to page number 2, we want to review some of the major purchasing functions. And I'm going to walk through these, and where I think there may need a little clarification, I'll try and clarify what these particular data elements or functions represent. The first one is supplier selection, and that is really the analysis by purchasing of the supplier. Secondly, supplier analysis, and that is to analyze all of the potential data elements that you would include in supplier selection. Some of the requirements of analysis would be the quality issue, the delivery issue, and the accuracy of, let's say, the shipping quantities. The next item is quite self-explanatory, issue purchase orders, but the following item is one of the most critical elements in purchasing, and when maintenance management is not supported by a full-time dedicated purchasing professional, we start to have problems in our maintenance work order planning and scheduling system, and that is the follow-up of supplier delivery promises. It is the purchasing department responsibility to follow up with suppliers to make certain that all of the due dates are met according to the purchase order requirement. The next item would pertain to quotations, and next is price negotiation. And here it's not a bartering or a competitive negotiation. It's merely comparing, let's say, one supplier's price to another, and if there is a higher price established by another supplier, but that supplier has good quality, delivery, accuracy of counts, a very stable supplier, here's where we may want to negotiate to try and get that price down to a competitive posture as compared to another supplier. We also get into market analysis, and this is not market research, it's merely market analysis. And that is, what are industries doing to provide products that would give us higher quality, longer longevity at least cost? I could cite two different industry examples. One would be in the lighting, or what some people refer to as the luminary field. We are getting a type of lighting equipment that lasts longer, gives us more lumens, at a reduced price. The other would be in the motor industry, where now we are having the same horsepower of a motor, where it's actually generating or utilizing, I should say, less power consumption, and it is providing longer lifespan of operation. So those are two of the data elements relative to market analysis. We get into purchase price analysis, and that could be, again, a competitive analysis, or it could be obtained through your quotation system. Tracing supplier shipments is exactly what that indicates. Now, the sale of scrap and surplus is a very important issue relative to maintenance items or the final disposition of your assets. The easiest way that I have found to support that type of an activity in purchasing is to work with what I call bonded scrap dealers. A bonded scrap dealer will provide you with the documentation which is notarized and will indicate that your material will either go into what we call a smelting operation, or it may go into what is called a bonded, let's say, landfill program. Remember, you don't want to have any of your spare parts or assets, may they be obsolete or, let's say, non-functional. You don't want these types of items to find their way out into the marketplace. Alternate suppliers are a key consideration where you have, let's say, large volume or critical items. You definitely want to consider more than one supplier for that type of a commodity. Verifying the quality and quantity is an integral part of the purchasing responsibility, but the people that are doing the receiving, inspection, and the actual counting of the receipts from supplier shipments is the storeroom. So there is a integrated requirement between purchasing and the storeroom or warehouse when it comes to receiving and receiving inspection. And when we get into some of the data a little later in this section, we're going to address the quality issue as well as the quantity issue. The next is another key requirement of purchasing, and that is approving vendor invoices. Now, the next two items we incorporate into this list of many of the activities of the purchasing department, but it is not purchasing's responsibility to develop penalty clauses, or the next item indicates legal aspects of contracts. There you should get your house counsel to support any type of language that is required. You must be thoroughly trained in terms of the language, some of the penalty applications, and then it may be up to you in purchasing to transmit that information to a vendor. And in a lot of cases, we recommend that maybe the house counsel, along with you in purchasing, works specifically with the vendor or vendors where you have those types of applications. Issue, delivery, and shipping instructions would be that information which is required by the storeroom to either return rejected or other types of material to a supplier, or send, let's say, items out for repair. And the next item, issue billing terms, is really a function or the responsibility of finance to support purchasing's position in the billing and terms area. And the next item indicates various reports to management. And again, the easiest way to develop the reports is to sit down with different management personnel and determine what they would like to see coming out of the purchasing department.